Good morning. I am Srinivasan Selvaraj. My mobile number is country code is +91 India, and my mobile number is 7550246567. My company name is SSI Embedded Foundations. We are basically doing research and development in embedded system and embedded system devices, and also we are providing excellent embedded system training from India, Chennai, and our email address is ssembeddedchennai@gmail.com. ssembeddedchennai@gmail.com. Today we are going to see memory organization of a microcontroller. In this example, we are taking PIC system 16F877A. Okay, there are 3 memory blocks in each of the PIC system F877A devices. What are the memory? Not only in PIC, if you take any microcontroller processor, you have the 3 memory blocks. The program memory and data memory have separate buses so that concurrent access can occur, and is detailed in this section. I already explained program memory, data memory, and RAM. Okay, the EEPROM data memory block is detailed in section 3.0. Data EEPROM and flash program memory. Program memory organization. The PIC system F877A devices have a 30-bit program counter capable of addressing an 8K word 14-bit program memory space. So in this block diagram I explained the output of the program counter is connected to flash program memory of input, that is address bus. This program counter is 13-bit. So 13-bit program counter capable of addressing an 8K word into 14-bit program memory space. The PIC system F876 and 877A devices have 8K words into 14 bits of flash program memory. And if you take PIC 16F873 and 874A, devices have 4K word and 14 bits. Accessing a location above the physically implemented address will cause a problem. The reset vector. What is memory reset vector? If you power on, the program counter will point address, that is called reset vector, is at 00H. It starts from 00H. And the interrupt vector is 004H. Interrupt address, hardware interrupt address is 004H. If we take the program memory organization map, program memory map, and stack pointer, program counter is 0 to 12 bit, output is 13 bit, it's connected to addresses. So address start from 00H and it end from 1F of H in PIC system 877A. Okay, and program memory is divided by page 0, page 1, and page 2, page 3. Okay, in this diagram, reset vector is 00H and interrupt vector, hardware interrupt address vector 004H. That means if any hardware interrupt occur, the program counter will give output of 0004. So the program memory address becomes 004. There, whatever instruction, whatever the program you are downloaded, you are burned, your program, that instruction will be executed. And also in this microcontroller program memory, you have the stack pointer, stack level 1, stack level 2, up to stack level 8. The data memory organization. The data memory is partitioned into multiple banks which contain the general purpose registers and the special function registers. Data memory RAM is partitioned into multiple banks which contains the general purpose registers and the special function registers. Bits RP1 and RP0 and RP1 no in status register. There's a register is called status register. In that, bit RP1 and RP0 are the bank select bits. So program memory is divided into pages, page 0, page 1, like that. Data memory RAM is partitioned into multiple banks, bank 0, bank 1, bank 2, bank 3. Each bank is selected using bits in the status register. That bits are called RP1 and RP0. So in a status register, RP1 and RP, we will see elaborately about status register later. So there is a register called status register. In that there is a bit called RP1, RP0, RP1 and RP0. If RP1 or RP0 is 000, then bank 0 will be selected. If RP1 RP0 is 01, bank 1 will be selected. And if it is RP1 RP0 is 10, bank 2 will be selected. If RP1 RP0 is 11, bank 3 will be selected. So in PIC session-5 877A, program data memory RAM is divided by bank 0, bank 1, bank 2, bank 3. Each bank is selected by RP1 RP0 bits available in the status register. Then each bank extended up to 7FH, 128 bytes each bank. The lower location of each bank are reserved for the special function register, SFR. What is the function of special function register? That registers are used to configure IO operations and ADC and peripherals. Okay, special function registers mainly used to configure or used to store bits for operating for working IO units, peripherals. Above the special function registers are general purpose registers implemented as static RAM, data memory. All implemented banks contain special function registers. Some frequently used special function registers from one bank may be mirrored in another bank for code reduction and quicker access. Then, general purpose register file. The register file can be accessed either directly or indirectly through the file select register, FSR. I already explained direct addressing and indirect addressing in previous section. Then this is the session-5 877A and 876A register file map. It starts from 00, each bank, this is the bank 0, start from 00 and end with 7F, bank 0. And bank 1 start from start from 80 and end with FF, and bank 2 start from 100 and end with 17F, and bank 3 start from 180 and end with 1FF. Okay.